right, so we're talking about section 1.1. We've been talking about solving linear equations in this section. So this is my last wrap up for section 1.1. The last competency for 1.1 is to be able to solve formulas, to rearrange formulas, called solving for a specified variable. And so the last few problems in your homework will address this situation. It says formulas, if you're following your handout for 1.1, the last little part of page 2 says formulas are used to model a situation. Some sample formulas that we'll see in this semester would be, for example, I equals PRT, which is a simple interest equation. We'll be using that sum along. D equals RT, which is the distance equation. Y equals mx plus b is in the graphing section. And then this last one, P equals 2L plus 2W, models how to find the perimeter of a rectangle, actually. So, for example, if we had a rectangle and we know that there's the lengths are the same in a rectangle and the widths are the same. So perimeter is the distance around that rectangle. Perimeter would be 2 of these plus 2 of these. So normally, you're solving a normal problem, you would just be able to plug in to the equation the way it's solved for P naturally. So if you knew the width was, say, 3 inches and the length were, let's say, 7 inches, you could say, well, I know there's 2 of the lengths, 2 sevens, plus 2 of the threes, 2 threes, and that would tell you the distance around. Or you could simply say it's 7 plus 3 plus 7 plus 3. This formula would help you to know that, the distance around your rectangle. Well, what we do sometimes, say, I don't know that this is a common thing to happen, but it could come up in a geometry question. You knew that the perimeter, that the length was 7 inches, and you knew the perimeter was, say, 52 inches. Can you figure out what the width is? And yes, we can with this formula. But what we would be asking ourselves is, what is W? We know the length, but we don't know the width. We know the perimeter. So we could put it in this formula. Perimeter is 52. The length is 7. So we change the length to a 7. And we don't know the width. So we would solve this equation, and maybe you just kind of could figure that out in your head. But if you were doing a lot of these, it would be handy to rearrange the equation for the W, to rearrange it in terms of W. So if you're going to do a repeated amount of computations, it makes sense to rearrange an equation for one of the variables. So instead of doing this repeated amount of times, let's once and for all rearrange the equation. P equals 2L plus 2W. Let's solve it for the W. Just rearrange it for W. And that's this last little thing that you're doing in section 1.1. You're rearranging equations. So I would say whatever 2L is, I'm going to throw that across the line, subtract it, whatever that number, it's a positive number, throw it across and it will make it minus, like so. And then to get W completely along, we would divide out the 2. And now we would have rearranged the equation in terms of W, or solved it for that specified variable. And it would be P minus 2L divided by 2. Or you could rewrite it in the left side, W equals P minus 2L over 2. So now we could say, okay, back to our example. Instead of having to solve it like equation-wise each time, we'd say, okay, the perimeter was 52, the length was 7, and then I'm able to just type that in my calculator without having to do any equation repeatedly, any algebra, I guess, repeatedly. And we could figure that out if needed. So that's the idea for this last little blurb here, is let's solve lots of equations, rearrange them for different variables. So the next one we're going to look at, let's see, I'd kind of do it again on the next page. This time I solve it for L, just to repeat the process. So look at this next practice problem. We've got this same equation, and this time I've been requested to solve it for the L instead of the W. So let's see. Again, feel free to pause and try that on your own. But let me reveal that. If you're solving for the L, I want to throw the W term across. So notice it's P minus 2W equals the 2L. So that's going to be the same procedure for all these. You gather whatever term you're asked to solve for, figure out in the direction, gather that to one side, and throw any other terms to the opposite. So you're just rearranging terms, gathering the variable asked to solve. Then you divide out the 2 to get the L alone. So we divide both sides by 2, and then there is our solution, solved in terms of L this time. All right, so here's a you try. Again, feel free to pause the video, but I'm going to go ahead and distribute. This one has some distributive going. And this time it says solve for X, kind of typical, back to kind of the original idea, but there's a lot of variables in this one, so it's a little different than before. But so whatever variable you're solving for, gather it to one side. So we've got the 2x on this side, and we'll bring the 3x over. 2x and minus 3x, I'll actually be able to combine those. But these other terms that I don't need go to the other side. So rearranging, just throwing terms around, changing their sign as they switch sides. So that becomes a plus 2a, that becomes a minus b on the right side, and I already had an a sitting over there. So then we combine the 2x and the minus 3x actually combine to be negative 1x. And then we got 2a and 1a. You know, anything that's combinable, you want to do that. So we're almost there. We've got x almost alone, but it's negative. You always have to get rid of the negative sign as well. So divide by negative 1 on both sides, which will basically change the signs of this side, 3a and a plus b. And now you've solved it. It's not like x equals 3 like we like, but it is solved in terms of x, with the x isolated and everything else on the other side. All right, so you might call these too many variables going on. All right, let's try another one. The practice problem I have for you next. Also, too many variables, you know, is the theme. So let's look at this one. This is another geometry type formula where you're solving, actually I think it's surface area of a box, and it says solve for h. It'll always give you the variable that it's asking you to solve for in these. So if we're solving for h, we want to gather is my word. I gather the h terms to the left or right. You know, pick a side and rearrange. And then, okay, so I've done that. Let's see, how many h terms? This one has an h in it, and this one has an h in it. It might help to kind of visually circle those. I'm going to leave those. I've left them on the right, but this 2LW, throw it to the other side, which made it minus 2LW. So that's gathering the variable I need. Well, this time I can't combine. Like in the previous example, the x terms were combinable. The h terms are not like terms. Okay? You cannot combine those. So since they're not like terms, you will be able to combine them. The trick is you will factor, and divide the h alone. So again, there's h in both of these terms, and the key, if you can't combine them, you factor. So we factor out the h. Again, the h in both of those, factor out the h, it leaves a 2w and 2l equals the other side. And then because that's times, just as if that were a number, we divide that onto each side. You can see here, divide, cancels it off of that side and leaves h solved for. It makes kind of a mess of the other side, but you know, we're following the rules, and that is the appropriate answer, solved in terms of h. If you had to do repeated problems solving for the height of a box, basically, surface area, you'd be able to find the height of a box with repeated calculations that way. Okay, so I have a you try for you. Number 3, you see below. Think about how you can solve that one for the p variable. So again, you look at all your terms, count your terms. I have 1, 2, 3 terms. And a good point I might make here is what makes something a term? A term is things that are multiplied together, like this is all kind of stuck together. That counts as a term, one term. But these are individual, 2 separate terms. You know, a plus or minus sign will divide terms. Remember up here we had actually, what did we have? 4 terms. The s is a term, then 1, 2, 3 more terms. So those are all individual terms separated by a plus or minus sign. So in this problem here, you have 3 terms, 1, 2, 3. So if you're asked to solve for p, find all the terms that have a p, which would be 1, 2, and get them to the same side. So I'm going to leave the a on the left side and take this minus p to the right, which will make it positive p, and then put a plus since that's a positive PRT. So now we have the p variable, or the p terms, collected or gathered, I call that. And they can't be combined, and it's always nice if you can't, but you can't combine those like terms. They're not like terms. So factoring, remember that's the key. When they're not combinable, you have to factor. So to get the p variable alone, we factor those two terms. We have to leave a one place for p1 to be p, hold that place, and p times the rt, make p times rt is PRT. You know, check if you redistribute that, that is true, okay? P times 1 is the P times RT is the PRT. All right, so this now is a multiplier. When we factored P out, it's multiplied by that. So we can divide out this quantity to cancel it off of that side, and then we have to do the same thing to the other side. And so our solution is P equals A over 1 plus the RT. And so that would be the rearranging or solving for the specified variable correct answer. All right, I hope that helps as I go through for that section. You'll also see some videos below where I work out some of your homework problems, some sample homework problems. So feel free to use those if there's anything that you feel is missing in this lecture part and you need more guidance. You can watch some of the sample videos. All right, I hope that helps, and best wishes to you for success.